So we have all four of these shapes, and we can look at the different properties, and we'll be determining if the given shape, so I'll give you four ordered pairs, if I connect them in order, what kind of shape do they create? So parallel sides will have the same slope, perpendicular will have opposite reciprocal slopes. So if I gave you one slope of -4/3, what does the other slope have to be? 3/4 and positive. So flipped and opposite signs. And then congruent sides would have the same distance or length. So we find that using the distance formula. So we're going to be sketching each shape, putting together the letters in alphabetical order. So you need to know how to connect the shapes. If I tell you this is quadrilateral ABCD, you just graph them in order or track them in order. Then answer the following questions. Consider the properties of the specified quadrilateral. So example, this first one here. It says quadrilateral ABCD is a parallelogram with points A at 4, 8 and B at 0, -2. So first let's just sketch this thing. So if I have a quadrilateral, looks like this, and it's a parallelogram, so I'm going to draw it as such, try to, it doesn't have to be perfect. If I put A in this top corner, then B would have to go here, and I'm just going to go around the whole figure. So C here and D here. Which sides will have the same slope? So AB will have the same slope as which side? DC. Those are parallel, so parallel sides have the same slope. And AD will have the same slope as BC. Which sides will be congruent? So AB will be congruent to which side? If this is a parallelogram. AB and DC. And AD,
it's just the same thing.
Yep, AD will be congruent to BC because it's a parallelogram. Okay, jumping into the next question. What's the slope of AB? So use the slope formula. So we go from, let's go from 8 to the -2. So 8 minus -2, so +2, over 4 minus 0. 8 minus 2 is, or 8 plus 2 is 10, over 4 minus 0 is 4. So 10 over 4 reduces to 5 over 2. What's the length of AB? So we're going to use the distance formula. And we don't really have to work too hard because we just found the distances, right? We just found the change in our x's and the change in our y's. So we could say that's 10 squared plus 4 squared. 10 squared is 100, plus 4 squared is 16. What's the square root of 116, approximately? 10.8. So if this is a parallelogram, what's the slope of CD have to be? Same thing as AB. So AB and CD are parallel, so they'll have the same slope, so it should be 5 over 2. The length of CD should be the same. It should be 10.8. Questions? Flip to the next page. Quadrilateral ABCD is located at, A is located at -2, 6, B is at 1, 2. Find the slope of AB. So let's sketch it. It just says quadrilateral, so I'm just going to draw this as a parallelogram and go from there because that is the least specific. A, B, C, D. What is the slope of AB? So we're doing the same thing again. So I'll go 6 minus 2 on the top, -2 minus 1, So 4 over -3, which I can simplify to -4 over 3. So just bringing the negative sign to the top. So that was AB. What must the slope of DC be in order for it to be a parallelogram? -4/3. Number 2, if ABCD is a quadrilateral, A is located at 0, 3, B is located at -2, 5. So again, sketch it. A, B, C, D. Find the length of AB. So distance formula, length of AB. So 0 minus -2, so 0 plus 2 squared plus 3 minus 5 squared. 0 plus 2, so 2 squared, plus 3 minus 5, so -2 squared. So 4 plus 4, square root of 8, is approximately 2.8. So if AB is 2.8, what must the length of BC be, so this one here, for ABCD to be a square? Must be also 2.8. If it's a square. If it was a rhombus, 2.8. Okay, these next two questions are me just giving you each of the coordinates A, B, C, and D, and you are going to classify by finding the sides, the length of each side, and the slope. So we'll walk through number 3 together, and you'll do part of 4 on your own. So we're going to find the distance and slope of AB first. So distance equals, and remember, once we find the distance, the slope just becomes faster because we've already calculated. So from A to B, so I'll go from -1 minus 3 squared plus 1 minus 3 squared. -1 minus 3 is -4 squared plus 1 minus 3 is -2 squared. I am going to write these out instead of going ahead and just like squaring them in my head. That way it just becomes a little bit easier for me to use the distance formula to convert that to slope. And if you want to make sure that you're using the right order, I did change in x's first and then the change in y's. So when I go and do my slope, I know which number would go on top. The -2 would go on the top, and the -4 would go on the bottom. So this becomes 16 plus 4, which is square root of 20. What is the square root of 20? 4.5. And our slope, we've already kind of started that. -2 over -4 reduces to 1/2. All right, now BC, maybe we want to sketch this just to kind of see what it looks like. If you just sketched it, and on your homework I do ask you to sketch. So we know that AB is 4.5. Now let's find the length of BC. So if I use my distance formula, BC, so 3 minus 0 squared plus 3 minus -6, so 3 plus 6 squared. So that was my change in x's and my change in y's. 3 minus 0 is 3 squared plus 3 plus 6 is 9 squared. 3 squared is 9 plus 9 squared is 81. So square root of 90. What do we get? 9.5. So if BC is 9.5, which two shapes have we just narrowed it down to? If these lengths are different, it cannot be a square and it cannot be a rhombus. So it could still be a rectangle or a parallelogram. Not sure yet. So let's find the slope to determine. So if I use my change in y's, 9, over my change in x's, 3. Let's reduce that. 9 over 3, what's 9 divided by 3? 3, or 3 over 1. Are these opposite reciprocals? No. So they are not perpendicular. So these two sides are different lengths. They're not perpendicular. So I'm thinking, what shape? Parallelogram. I have to make sure that these match in order to determine, for sure. So just repeating the process. So for CD, let's find the distance. 0 minus negative 4, so 0 plus 4 squared, plus negative 6 minus negative 8, so negative 6 plus 8 squared. So that was my change in x's, change in y's. So 0 plus 4 is 4 squared, plus negative 6 plus 8 is 2 squared. If you stop right there and just throw that into your slope formula as well, you could. So 2 on the top, 4 on the bottom, and then continue. Whatever kind of makes sense in your head to do. 4 squared is 16 plus 4, so square root of 20, which we've already calculated is 4.5. 2 over 4, reducing that to 1/2. So we've just proved that CD is 4.5, and it's also parallel to AB because they have the same slope. Now let's check DA, or AD. So distance equals square root of negative 1 minus negative 4, so plus 4 squared, plus 1 minus negative 8, so plus 8 squared. The only reason these changed to plus is because it was minus a negative. So we have 3 squared plus 9 squared. So that's 9 over 3 for my slope. So 9 plus 81, square root of 90, which we've already calculated is 9.5. 9 over 3 reduces to 3. So we've now proved that AD is the same length as BC, and they have the same slope, so they are parallel. So yes, this is for sure a parallelogram. Questions? Okay, let's do one more of those. So first, finding the length of AB. So distance formula. 0 minus 3 squared plus negative 1 minus 1 squared. 0 minus 3 is negative 3 plus negative 2 squared. Negative 3 squared is 9 plus negative 2 squared is 4. So that's square root of 13. What is the square root of 13 approximately? 3.6. I might even go ahead and sketch this shape. And I'm just sketching a basic looking parallelogram. A, B, C, D. So AB is 3.6. Let's find my slope of AB. So this was my change in X. This is my change in Y. So negative 2 on the top, negative 3 on the bottom. That can just reduce to 2/3. The negative signs cancel each other out. BC, distance. 3 minus 5 squared plus 1 minus negative 2, so 1 plus 2 squared. 3 minus 5 is negative 2 squared, plus 1 plus 2 is 3 squared. So this is 4 plus 9, square root of 13, which we already did just calculate, 3.6. So we know that BC is 3.6. These two sides are the same. What two shapes have we narrowed it down to? Rhombus or square? If BC slope is perpendicular, it's probably a rhombus. If they're perpendicular, it's probably a rhombus. If they're perpendicular, square. Okay, if they're not perpendicular, probably a rhombus, but we still would have to verify by checking the other two sides. So slope, here's my change in x's, here's my change in y's. So it's 3 over negative 2. Typically, you just bring the negative sign to the top, so negative 3 over 2. Are those opposite reciprocals? Yes. So that means this is a right angle, right there.
That means it's a square.
That means it's a square, but we still need to verify with these two sides. We can't just stop there, because that means that these two sides are congruent and perpendicular, but we have to prove. So remember, proofs, we're proving it by finding all of these sides. So CD, but now that we know square root of 13 is 3.6, it gets a little bit faster. So 5 minus 2 squared plus negative 2 plus 4 squared. 5 minus 2 is 3 squared plus negative 2 plus 4 is 2 squared. So slope, that's 2 over 3. So 9 plus 4, that's square root of 13, which is 3.6. Slope is 2/3. So I know that this side's the same, and they are parallel. That's what I've just proved. Lastly, length of DA. So D to A, so 0 minus 2 squared plus negative 1 minus negative 4, so plus 4 squared. So we got negative 2 squared plus 3 squared. So that's 3 over negative 2 again. 4 plus 9, square root of 13, 3.6. Slope is negative 3 over 2. So yes, this is for sure a square. And the last two questions is finalizing, so finding the fourth ordered pair of your shape. So we have to be able to graph. Using the points given, choose the final points that will create the requested quadrilateral. Justify your answer on the coordinate plane. Show the slope. So, create a parallelogram ABCD given the points. So these are x, y ordered pairs. We have to be able to graph these. This is, again, pretty good review for that EOC. So negative 2, 3. So I start at my origin and go left 2, up 3. And I plot A. Then 4, 3. So start back at my origin, go right 4, up 3. And here's B. C is at negative 1, negative 2. So start my origin, left 1, down 2. C. So does point D have to be to the left of C or to the right of C? Would it be here where my finger is or about here where my pen is? Has to be to the left because it's in alphabetical order. I want to go A, B, C, D, and then try to connect those. Okay, it has to be in order. So A to B to C, and D should be over here. How do we find that? We use our slope. So my slope from C to B was, or maybe I go from B to C so I can go from A to B, A to D. So I would go down 1, 2, 3, 4, 5. So down 5. To the left, 1, 2, 3, 4, 5. So down 5, left 5. So from A to D, I'm going to go down 5, 1, 2, 3, 4, 5, and left 5, 1, 2, 3, 4, 5. That means D has to be right here, and we need to find the coordinates. So take a second and count and find your ordered pair for D on your own. I counted left 7, down 2, so that ordered pair should be -7, -2. Next one, create a rectangle, ABCD. So this is our last question, last one. Create a rectangle. So if A is at -2, 4, so left 2, up 4. A is here. B is at 2, 2. So I'm noticing those aren't on perfect crosshairs, so I'm going to have to use a slope for sure. C is at -1, -4. Left 1, down 4. C. If you connect as you go, maybe it gives you a better visual of where D has to be. Okay, D has to be over here somewhere. So I'm going to use my slope. From B to C, I went down 1, 2, 3, 4, 5, 6. So down 6, and to the left 1, 2, 3. So left 3 is -3. So from A to D, I'm going to go down 6, left 3, 1, 2, 3. So D should be here. If I connect those, it should create a rectangle, and it visually looks like it does. If I find that ordered pair, that's left from my origin, 1, 2, 3, 4, 5. Left 5, down 2, so -5, -2.